Hi everyone. Our team is about to present safety system, that is passive safety system, which activates after when a car gets into an accident or car get collide. Airbags. Once a crash has been detected, a flexible bag is rapidly inflated with a gas that is released from a container by an electrically ignited chemical component. Ideally, the airbag inflates in sufficient time, that is typically less than 50 milliseconds, to act as a cushion for the driver or a passenger as he or she is thrown forward or sideways during the crash. A typical airbag will require about 30 milliseconds to inflate, meaning that crash must be detected within about 20 milliseconds. With respect to the speed of the modern digital electronics, a 20 millisecond time interval is not considered to be short. The complicated factor for crash detection is many crashes like acceleration, deceleration experienced by the typical car that could be interrupted by airbag electronics as a crash, such as impact a large pothole on driving over a curb. The, the configuration for an airbag system has also evolved from an electromechanical implementation using switches to electrical system employing sophisticated signal processing. One of the earliest configurations that was intended to protect the occupants from longitudinal axis deceleration employed a pair of acceleration switches, switch 1 and 2, that is depicted in the under figure. Each of these switches is in the form of mass suspended in a tube. The tube axle aligned parallel to the longitudinal car axis. The two switches, which are normally open, must be closed to complete the circuit for firing airbag. When the circuit is complete, a current flows through the igniter that activates the charges. Gas is produced essentially explosively that inflates the airbag. Switch 1 and 2 are placed in two separate locations in the car. Typically, one is located nearer to the front of the car and one is near the front of the passenger compartment. Some automakers locate a switch under the driver's seat on the foot pan. Referring to the sketch in the figure, the operation of the acceleration sensitive switches can be understood. Under normal driving condition, the spring holds the movable mass against a stop and the switch contacts remain open. During a crash, the force of acceleration, actually deceleration of the car, acting on the mass is sufficient to overcome the spring force and the move of the mass. For sufficiently high car deceleration, the mass moves forward to close the switch contacts. In a real collision at sufficient speed, both switch mass will move to close the switch contacts and thereby completing the circuit and igniting the chemical components to infiltrate the airbag. In modern system, the structure of airbag is depicted in the under figure. An airbag consists of a sensor that detects the frontal collision and ECU, electronic control unit, that decides whether to deploy an airbag or not based on the signal from this sensor. An inflator that produces gas. These structures are shown in the figure, I mentioned it already. The bag that inflates to protect the passenger and the driver. When the vehicle decelerates due to a collision, the sensor detects the deceleration. This sensor is an electronic accelerator. The ECU decides whether to inflate an airbag or not based on the waveform obtained from the time of collision. Its sensor may detect the vehicle acceleration whose impact compares to the collision. Such when the vehicle collides against a curb, when the vehicle is tampered, the waveforms are obtained from the frontal collision sensor. When the ECU decides that an airbag should be inflated, ignition current is applied to the inflator. The ignition ignites the gas generated material and generates the nitrogen gas inflate the bag. This process from collision to the bag inflate should be complete in 10 of milliseconds before the driver's upper body hits the steering wheel. After the airbag has been inflated fully, a gas slightly removed to reduce the surface pressure to absorb the shock that the driver and passenger receives. In case of ECUs not supplied with the power by battery due to the disconnection, resulting from the collision. The ECUs given a backup from the capacitor. Our team member Sam Daniel will explain about seatbelt and its mechanism.
The pre-tensioner consists of an inertial wheel combined with a pendulum which moves to the clock. The belt into place during sudden deceleration. Most drivers have experienced the frustration of pulling a seat belt from its reel only to have it lock unexpectedly, or to be driving down the road and experience the seat belt gradually getting tighter and tighter. This is the action of the mechanical pre-tensioner work. The electric pre-tensioner replaces the pendulum with the electrical sensor. This prevents the false locking condition that is commonly observed with the mechanical pre-tensioner. The electrical sensor can also be interconnected with the other system on the vehicle, such as rollover sensor or airbag sensor. This connectivity ensures that the seat belts will lock even if the sudden deceleration that is needed to lock a mechanical pre-tensioner does not occur. This pre-tensioner operates with a ECU and a gas generator system in a similar way to the airbag. In fact, the electronic pre-tensioner usually work together with the airbag and may even use the same ECU as the big airbag, and that increases its effectiveness. The pyrotechnic pre-tensioner is the most sophisticated type of pre-tensioning device. The electronically triggered pyrotechnic device not only locks the seat belt in place but tightens the belt to take up any slack that may be present, minimizing the moment of occupant with the vehicle during a crash situation. Once a pyrotechnical pre-tensioner is activated, it must be replaced. An explosive charge is used and causes the gas generator to produce this volume of gas produced a pressure which acts on a mechanical linkage to pull the seat belt. This pre-tensioner is usually located in the B pillar. Both pre-tensioners are designed to slacken off slightly around the same time the airbag deploys. This can be around 30 milliseconds after the collision. This slight lapse allows the passenger to have a control contact with the airbag.
Hi sir, I am Vairamuthu. My team project is passive safety system. The passive safety system whiplash that is that the commonest injury in car crashes. The whiplash motion can strain and sometimes even rupture the discs that separate the vertebrae. When the disc gets damaged, the injured person may be experience extreme pain and other unpleasant sensations in the neck. In a rare in a rare impact, the sheet is accelerated forward with the car due to the inertia of the occupant. The rear of the occupant is then pressed into the sheet. When the forces from the occupant acting upon the sheet backrest exceeded a particular level, the WHIPS system are going to activated. Hence, no external sensor system is requested to be activated. The WHIPS system. The aim of primary phase is to let the occupant sink into the sheet, thereby reducing the space between the top and therefore the headrest. To make an initial rearward motion of backrest, which does not move the top sternate far away from the top. To stay occupant, acceleration level low. The acceleration level is low by letting the backrest move rearwards, controlled away. This is often accomplished by the primary phase being a rearward motion of the seat backrest. The character of this motion being essentially translational, example without rotation. However, depending upon the pre-impact posture of the occupant, the motion characteristics of the backrest are to some extent adaptable and should the occupant position relative to the backrest. Thank you, sir.